Hello guys, it's IT Shiesty again, and today we're going to be going through the second video in our OSI model series, and that is the data link layer, layer number 2. So the data link layer is like a bouncer at the club. It makes sure that every bit of data has the right address and no errors before letting them in. And just like a real bouncer, it's seen a lot of corruption, like literal data corruption. The data link layer. The data link layer is the second layer of the OSI model, and it is responsible for managing data transmissions between devices on the same network. So what is the data link layer? The data link layer sits between the physical layer and the network layer. The physical layer deals with the physical transmission of bits over the network median, such as cables or wireless signals, and the layer that we're talking about today is the data link layer, which handles the data transfer within a local network. A local network, often referred to as a local area network or LAN, is a group of connected devices within a limited geographic area like a home, office, or school. It allows devices to communicate, share resources such as files and printers efficiently. In a local network, the data link layer manages how packets are formatted for transmission. For instance, in Ethernet networks, it deals with MAC addresses to identify devices uniquely, and I'll be talking about MAC addresses later in the video. So this is our local area network. Then once we connect to the internet, we'll have to go through our ISP, which for this instance is Telstra. Functions of the data link layer. Framing. Dividing into frames, which are small units of data with headers and trailers for control of information. Error detection and correction. Ensuring data integrity by detecting and correcting errors during transmission. Media access control. Managing access to the shared network medium, ensuring efficient data flow between multiple devices. Flow control. Regulating data transmission rate to prevent network congestion and ensure smooth data flow. Framing and encapsulation. Data, the actual information being transmitted. Header. This contains information such as the destination address and the frame type. Now the trailer contains error detection and correction information to ensure data integrity. As we can see here, we're at the data link layer. The data is usually in frames, and when it gets to the network layer, it is then turned into packets, and then here in the physical layer, they are usually stored as bits. Framing. Framing is the process of defining boundaries within the data stream. Each frame contains a header and a trailer, which allows the receiving device to understand where the frame starts and ends. De-encapsulation. Upon reaching its destination, the frame undergoes de-encapsulation. This process is the reverse of encapsulation. So when you receive a frame, it starts the de-encapsulation process, and it strips the header and the trailer into just the data, and usually in the physical layer that will be raw bits. So yeah, here we are in the data link layer in this section here, and we can see that when we're sending something to another receiving computer, they de-encapsulate the data from physical bits into frames, and then into the network layer into packets, and then into segments in the transport layer, and then into just the data for the presentation session and application, which we'll be going through in later videos. And now when we're sending something from the computer, we go down the stack. So it goes from application, presentation, session, transport to network. The data link layer, it goes from packets into the frames, which usually provide with source MAC addresses and destination addresses, into the physical layer, which is the raw binary bits that get sent over the Ethernet cables, fiber cables, or sometimes even Wi-Fi, and that gets sent over to the receiving computer, which will then de-encapsulate it from the frames, packets, or from the segments, and then it'll be readable data that the computer can understand. Media access control on MAC addresses. Unique identifiers. Each network interface card, or NIC, has a unique MAC address, a 48-bit number that acts as a physical address for that device. Addressing scheme. The MAC addresses are used by the data link layer to identify devices on the same network. They are hierarchical, with the first 24 bits representing the manufacturer and the last 24 bits representing the specific device. Every single device that connects to the internet has a MAC address card, just like your phone, your IoT device watch, your smart printer, your smart fridge. They all have network interface cards which also store MAC addresses which are unique. Now we just have an example of an organizational identifier, which is the brand, and then we have the universally administered address, which is unique in the whole world. Error detection and correction. Checksum. A simple error detection method that calculates a sum of the data bits and adds it to the frame trailer. Parity checking. An even simpler method that adds an extra bit to each byte of data to ensure an even or odd number of 1 bits. Cyclic redundancy check or CRC. A more robust error detection method that uses a mathematical algorithm to calculate a checksum. Flow control mechanisms. Stop and wait. Simple method where the sender pauses after sending a frame and waits for an acknowledgement from the receiver before sending the next frame, similar to the TCP three-way handshake. Sliding window. Allows the sender to send multiple frames before waiting for acknowledgements, improving efficiency. Logical link control, LLC. Now the LLC is just another sublayer of the data link layer. As we can see, the media access sublayer and the logical link control sublayer here inside the data link layer, and above the network layer, which we'll get into in the next video, and below the physical layer in which we spoke about in the last video. So addressing. The LLC sublayer manages the network layer addressing, allowing data to be routed across the network. Data exchange. It handles the exchange of data between devices, including segmentation and reassembly. Flow control. It manages the flow of data between devices to prevent network congestion. Devices operating at the data link layer. Network switches. Network switches learn MAC addresses of connected devices and forward the frames based on those addresses. So you're going to see a lot of switches inside an office, mostly Cisco switches. Right here is an 8-port switch. Network bridges. Connect different network segments and filter frames based on destination MAC addresses. Bit similar to a switch, but we'll get more into this in a different video. Wireless access points. Manage communication between wireless clients and the wired network, including authentication and encryption. So here we have a wireless access point, also known as a WAP. And no, Cardi B, we're not talking about that WAP. Practical applications and examples. So here, Ethernet is a common networking technology that uses the data link layer for framing, error detection, and MAC addressing. Now, it is also commonly referred to as Layer 2 addresses, which is the MAC address. Wi-Fi. Wireless networking protocol uses the data link layer for managing communications between wireless clients and the access point within that local area network. Conclusion. The data link layer works closely with the physical layer to enable reliable communication within a local network. The physical layer transmits the raw bits, while the data link layer organizes these into frames with addresses and error checking for accurate delivery. Well, that marks the end of the video about the data link layer, layer number 2. Now the next episode in this series will be about layer number 3, which is called the network layer. So I hope you enjoyed the video, I hope you learned something from this video, and I hope you can share it to your friends so then you can teach them something about the OSI model as well, as it is very important in networking, IT, all that. So thanks for watching, like and subscribe, please man. Anyway, IT Shiesty out.